Last unit we learned all about the rules of derivatives. In this unit we're going to use the rules of derivatives to help us sketch graphs. Let's go ahead and get started. The first thing I want to mention to you is that a continuous function assumes a maximum or minimum value on any closed interval. So, how is that? Well, if you have a closed interval, it means you have endpoints. So I'll just quickly draw a part of a function with a closed interval. Notice that this has to be its maximum and this has to be its minimum. So anytime we're talking about a closed interval, we will always have a maximum. And the second note I have is about a critical point. A critical point of a function is a point x sub 0, I'll name it, in the domain where the first derivative equals 0 or where it does not exist. Now I want to go ahead and talk about, really fast, the words critical number and critical point. So critical numbers, if you're asked to find a critical number, you only need to find the x value. If you are supposed to find the critical point, you need to find the x and the y values. So please take note of that so that you're answering questions properly. So critical number, just find the x value, but a critical point, you need to find the x and the y value. So we're going to be looking for critical points, and I have a sketch on the next slide that will hopefully describe this a little bit better. But again, it's where the first derivative is 0 or it does not exist. So in this picture here, I have lots of different crazy things going on in my graph. First of all, let me go ahead and just highlight what is the function here, since there's a lot of notations. I want to point out to you that every one of these arrows is considered a critical number or a critical point if you have the x and y values. Notice that this is a critical number because it's an endpoint, and the derivative does not exist at endpoints. Up here, this is a critical number because the derivative is equal to 0. Notice the slope of the tangent line to the curve is 0. Down here, this is a critical number because the slope is 0. The slope of the tangent line, that is 0. Up here, we know that the derivative does not exist because the derivative does not exist at cusps. Right here's another critical number because the slope of the tangent line is 0. Up here, again, we have another slope of the tangent line being 0. This ends up not being a max or a min or anything of great significance, but it's still considered a critical number. And then up here, we have another spot where the derivative does not exist, so it is considered a critical number. So hopefully this picture has shown you what critical numbers look like. Let's go ahead and continue on defining a few things that we're going to see in directions. The first one is extrema. Extrema is the maximum and the minimum values. So anytime you read the word extrema, know they're talking about maxes or mins. Relative extrema, or local, that's another word they could use, but relative is the one most common. Relative is it's not the highest or the lowest value, but it's still a critical number. So if I go back to this other picture, this was a local, right here, this is a local extreme. It's not the highest value. Up here is the highest value. Those highest values are called maximum or absolute maximum or absolute extrema. So it's the highest or the lowest extrema. So back to this picture, this is considered to be a local max. This one would be a local min. This seems to be the absolute minimum. This one would be the absolute max. This one is not a max or a min, it's just a critical number. This is another local or relative, I'll use that word this time, relative min. Remember that means the same thing. Local and relative are the same thing. And then this last one is another relative max. Remember, local and relative are the same words.